So we try to understand the free body diagram of a block sliding up the inclined plane. So as the motion is up the plane, suppose this effort is applied in this direction, and as the motion is up the plane, the frictional force will act in the opposite direction. So it is in the downward direction, and frictional force is given by mu r. Suppose the inclined plane is making an angle of alpha with the horizontal. As we know that weight will always act vertically in the downward direction. It will have two components. One is this component which is perpendicular to the plane. Another one is parallel to the plane. If this angle is alpha, this angle is also alpha, and therefore this component is mg cos alpha and opposite component is mg sin alpha. Normal reaction is always perpendicular to the surface of contact. So if this is the surface, the normal reaction will be always perpendicular to this particular surface. Now suppose we resolve this along this. This is the x-axis and this is the y-axis. So this is the positive x-axis and this is the positive y-axis. So forces along positive x-axis are P. This is the frictional forces along negative x-axis, and this mg sin alpha, that component is also along negative x-axis. Whereas this r is in upward direction, it is along the positive y-axis, and mg cos alpha is along the negative y-axis. So we apply the conditions of equilibrium, assuming that this is x-axis is nothing but this inclined plane is x-axis, and perpendicular to that is nothing but the y-axis. Now first condition is summation of fx is equal to 0. So P is positive because it is along the positive y-axis, as already we have seen. Mu r is negative because it is along negative x-axis, and mg sin alpha is also negative because it is also along the negative x-axis, and that is equal to 0. Similarly, applying the another condition of equilibrium, that is summation of fy is equal to 0. So this along positive direction, this is only normal reaction is there, which is along the positive y direction, so that is positive, so r is positive. Whereas this mg cos alpha is along the negative y direction, so minus mg cos alpha is equal to. So in this way, we can apply the conditions of equilibrium to the resolved forces. So suppose this is the sphere which is resting in a channel. It is having its own weight W, and we know that weight will always act vertically in the downward direction. This surface will offer reaction on the sphere, and it is shown over here. Similarly, this surface will also offer reaction on the sphere, and that is shown over here. And these reactions, they are perpendicular to this surface of contact. So this particular reaction will be perpendicular to this vertical surface. Similarly, this reaction will be perpendicular to this inclined surface. Now, as we can see, the line of action of all this, that is the weight W which is acting in the downward direction, these are the reactions. They will always pass through a common point, that is O. Suppose these are the angles which are made by this particular respective forces and reactions as shown over here. Now applying Lamy's theorem, you can say that W upon the opposite angle, sine of the opposite angle, that is W upon sine gamma is equal to R1 divided by sine alpha is equal to R2 divided by sine beta. So from this equation we can convert to various unknowns.